Okay, in case I have an unreliable car and can't actually make it to the like a place with the internet in time for the meeting, I wanted to talk about Mavros and publisher subscriber for serial communication. Uh, Basically, if you look here on my computer, you can see several different windows are open. Okay. The first one here is the Mavros core service. Okay. It's a standard Mavros core. Whenever you're using PX4 or ArduPilot, there's a corresponding one that shows up for it. But you need to have ROS turned on in the first place. Second thing is this isn't actually my computer, despite this beautiful keyboard and awesome mouse that I have here. It's actually Raspberry Pi, okay? And it's connected via this blue USB port or a serial port to the Arduino here. And my arm's about to give out, but the Arduino's attached to the simplest circuit of all time. It's just a LED in series with a resistor. And you can see it's blinking on and off every 1 second, or it should be something close to every 1 second. Okay? And when I look on my computer screen, we can see the code here that I've done to program the LED blink. It's literally the example code for the Arduino, but the only difference is that we want to communicate that the blinking is occurring over a serial port. So in order to do that, we just do serial.begin. This number 9600 corresponds to the speed, the baud rate that we want our serial interface to run at. And we're picking 9600 just because it's a good default value. There's some values that, I don't know, engineers like, so they commonly use 9600 as a common value. And down here, we can just see some loop code that runs over and over and over. And we're basically turning the LED on. We're printing that the LED's state to the serial monitor. We're waiting 1 second. We're turning the LED off. And then we're printing that the LED is off. And then we're waiting for 1 second. When I open the serial monitor here, we can see every 1 second. There's a little glitch when it first turns on, but every 1 second, the text displayed is LED on, LED off. And we can see up here that it's occurring on the device interface dev TTY ACM0, which is important, okay? Because when we want to use the publisher, which will be on this window, and the subscriber from Mavros, which will be on this window, when we're doing the publisher, we actually need to know what interface we're using. So if I open up, I'm going to just open up in my text editor. My favorite one is Vim. It doesn't matter. It's just to display text. If I open up the Arduino publisher here, I can see, there's a lot going on. The most important thing here is that we're using whichever ROS version we have available to us and the serial library for Python, okay? We instantiate the serial node object using the Python serial. And note here, we're selecting the location of the physical hardware, that's TTY ACM0, and the baud rate 9600. Okay, we initialize the ROS.Pi publisher and the node that corresponds with it, and then we have the rate set. So whenever ROS.Pi.rate has a number inside, that corresponds to that unit of that number is in hertz, and then we just activate the serial library to do serial.readline. We can see what the serial message says. We're taking our text, and then we're publishing it. The most important line here is pub.publish my text. Okay, and when we run this code, hopefully we'll see something like that. The message appears in the ROS node. Okay, so I'm publishing now. You won't see any output, or actually you will see any output. I just don't know why it was taking so long that time. But you can see here that the LED on and LED off is appearing. We can tell that it's actually happening here on ROS if we do ROS topic echo / I'm trying to keep this under 5 minutes in case I'm gone, but the only message, hopefully it might be a little longer, who cares? I have a great voice anyway. Tdrone / messages / ard state, and if I turn on ROS topic echo, I can see the raw data. Like the raw data that appears here, LED on, LED off, shows up here on the subscribe side. No problem. This is like a super easy thing to do. Okay? In a real sensor, like for example the VMR, there's some more advanced text parsing that could take place, either here in the Arduino side or here in the publisher side. You could just modify that code. It doesn't really matter where, I don't think. Maybe it does, and you'll have to experiment, but from my experience, it hasn't really mattered much at all. Okay? And then the other thing that we're going to do is, if we look at the we're gonna just look at this other thing called the subscriber. I'm trying not to type because I'm holding the camera in one hand and it's like Vim. Hold on, Mavros subscriber. Okay, and if I look here, I just start up the subscriber. It's super straightforward. It's exactly how Kyle described it. You know, you define your listener, you start it up by init node, and then you have the rosspy.subscriber line. And this part here is the actual name of the published thing that you're looking for. So if we look here, it's tdrone/messages/ard state. When we made the publisher, I'm not sure if I mentioned this, but when we made the publisher on this side, you know, we had the message tdrone/messages/ard state. So we knew that whenever we're looking for that message in the ROS.py or in the ROS network, that's the name that it's going to be. So cool. So yeah, I just do turn the publisher back on. We can see it's fired up. Then we can go here and we can turn the publisher on by doing Python mavros subscriber. Sorry, did I say turn the publisher on? That's I misspoke. We're turning on the subscriber here. Okay, when I do that, you know, it'll look mostly the same, right, as above here, right? LED on, LED off. We're just seeing that echoed here in the subscriber. Now, that might bring up the question, like, what is the point of the subscriber? And the answer is that whenever we use the subscriber, you know, when we used ROS topic echo up here, we could just see the raw data. We can't really work with it at all. So the subscriber gives us a space using the callback function to modify this data if we wanted to. I'm not going to do a demo of that because the video's rambled on long enough. It's just a really simple method of getting serial communication to run on the Raspberry Pi platform. Okay, thanks for coming to my TED Talk. It was a great one. I had a good time.